Hi and welcome to another of the DTA screencasts, and in this session we're going to be looking at the basic concepts of biomechanics. And what we're going to do first of all is identify some of the language and terminology that we need to understand, and we'll get started straight away. So principally the first thing that we need to look at is motion. So what is motion within sport and physical activity? So there's loads of different examples you could think of. So it's the principle of something moving, obviously, and it could be almost anything, but we need to look at them in a little bit more detail. So let's break them down. So the first type of motion that we talk about when we're applying biomechanics is this concept of linear motion. So as it says there, it's a straight or curved line. So it's the motion along that particular line, but the key principle is this here, is that all parts move at the same speed and direction. So if you look at the example there, all of that person's body is moving clearly straight down because they're skydiving. Same as that person's there, it's the entire body that is moving in that particular line. Okay, so we'll look at some examples in a minute, but we'll just we'll look at the other two different types of motion first of all. The next one is this form of angular motion. So this one is the movement within a circle or the part of a circle, but the key thing is the movement around a fixed point or axis. So as the gymnast rotates around that bar there, we can describe that as angular motion. Now let's see if we could apply that to this one here. Are they moving around a particular point? And the answer is no. So therefore they're moving in a straight line, and that gives us our linear motion. So straight line movement, where this one moves around a particular axis or a fixed point. And then the last type of motion is this general motion, which is a combination of linear and angular. Because if you think about the movement of the arm there, as it moves forwards and backwards, that's moving partially around the shoulder joint, and therefore that's angular motion. And the same application to the hip there, as that moves forwards and backwards, it's moving around that central point there, which is the hip, but the entire body is actually moving forwards, so that's a combination of the linear and the angular. So what I want you to do then is just have a look at these and see if you can pick out some examples. So pause the screencast, have a look at those and work out which ones are pure linear motion, pure angular, or general motion. So the next thing that we need to be able to understand is this concept of force. So what is force? I'm sure we could all think, when we think of force, we think of this aggressive action here, or maybe something not so aggressive as golf there. So let's have a look and see what it's actually defined as, which is really important for our studies. So it's this push or pull that alters or tends to alter the state of motion of a particular body. Now when we talk about body, that could be your entire body as a person, or it could be a ball. Either one of those, it's just a term that we apply to something that's being made to use. So a force is that which alters or tends to alter the body's state of rest or a uniform motion. So let's have a look at a sporting example to try and explain what that actually means. And what we're talking about is something being able to move something else by using force. So a simple example we can use here is the force applied by the golf club to the ball, therefore making it move. So can it move something that is still? Yes, it can. So force can do that. Other things that force can do: force can cause a body at rest to move, which is the one we've just looked at there. It can cause a moving body to change direction, accelerate or decelerate. So in a sporting context, if you think about somebody who passes you a ball, when you receive the ball you allow it to decelerate. But also by kicking the ball in the first instance, you're making the body, remember we said that could be a ball, it could be anything that you're striking or moving, so by you kicking it you can actually accelerate it. But also you can change its direction, so if somebody gives you a pass, instead of you stopping it directly, you can just like move it forwards and therefore change its direction. or if a ball hits the post, it's still going to keep moving, but it's going to change direction. The other thing a force can do is change the shape of an object. So this poor fella here, the ball's gone and hit him in the face, but because of the force of that, it's actually changed the shape of his face, but also the ball. But we'll talk about that when we look at Newton's 3 laws. Okay, so they're sporting examples of what force can actually do. So here's a sporting example for you to have a look at. So you can pause the screencast, have a look at it, and then, as it says there, look at the example and see where you can work out F, or force, and what effect it's actually having. So where in here could you describe the forces? So pause the screencast now and then have a look at those. Here's another one for you to have a go at. So you've got this tennis player here. Within this one, as an example, try and work out what types of motion are occurring, as well as the types of forces and what the force is actually doing. So what are the types of motion and what's the force actually doing? Okay, so again, pause the screencast and have a look at that. So the next little section we're talking about relating to force is what affects the force and the impact it will have on the particular body. And there are 2 factors. So the first is the size of the force, and also then the direction of the force. So if we look at this as a sporting example, the size of the force is how much force is being exerted from the club head to the ball, and therefore how quickly that will potentially go. And the other one is the direction. So is he hitting it in a straight line? If so, then this ball will probably move in a straight line and hopefully then go into the hole. Let's have a look at another example here. So the size of the force is going to have a significant outcome on this fella's face, but then also the direction of the force. So these things are related. So what we'll do then for this last part is link the force and the motion. Without force being applied, there basically won't be any motion, and that's whether it's actually a still object or a moving object, and that's as simple as it is. So if this person stays in the blocks, if there's no force applied by his muscles on the starting block, there'll be no change in the motion. And as this ball is rolling along, if nothing impacts upon it, then it will continue within that line until a force does act upon it. There you go. That's how simple that is, the link between force and motion. So we're going to move on to the laws of Newton, and he had 3 laws of motion, which we've kind of looked at to a certain extent, but let's look at them in a bit more detail. And they are the laws of inertia, acceleration, and action and reaction. So the first law, the law of inertia, it states that everything and everyone at rest or moving will with a constant velocity in a straight line will continue in that state unless acted upon by an external force. So in other words, that ball will stay exactly where it is until a force is acted upon it. So what are the forces that are acting upon it, or will be acting upon it? And you can obviously see that there's going to be a golf club that's going to be acting upon it, but also you've got gravity as well. So gravity is acting upon that ball there to keep it in its place. And this other aspect here, if something will remain in a constant velocity, so let's say the ball gets hit and it flies off, what forces do you think are acting upon it that will make it drop down and then potentially roll or not roll? So hopefully you've identified gravity. So as the ball flies through the air, gravity is acting upon it, so it will then drop down, but as soon as it hits the ground, something else is acting upon it, and that's the friction or resistance from the ground. So depending on what it lands on will depend on how further it will be able to roll. So there are always forces acting upon things, and if there are no forces that act upon things, then they will stay exactly in a state of inertia. So this person here, as he freewheels along, he will continually do that until a force acts upon him, and that would be the friction from the road and also the force of gravity. So There's just some other supporting examples you can have a look at there, so feel free to pause the screencast and have a look at those. But let's move on to the next one, and this is the second law of motion, and it's the law of acceleration. So this one is turning around and saying that everything is proportional, the speed of something increasing is proportional to the amount of force that's applied to it. So what that means in layperson's terms is how quickly something will move is depending on the direction and the speed of the force that's applied to it. How that sometimes looks is down here, so force equals mass times acceleration. So this describes those relationships between force, acceleration and mass. So if that was a huge heavy ball, then it would need more force applied to it for it to accelerate. So Newton identified that there is a link between those two things. So the force that this fellow is going to have to apply here is going to have to be considerable to move or accelerate that large object. And the force that this guy is applying to the shuttlecock is greater than the mass of the shuttlecock, therefore it will accelerate and go very quickly. But we'll look at these within our sessions. Okay, our third and final law is the action and reaction law of Newton. So within this, what Newton is turning around and saying is that for every action there is an equal and opposite reaction. Well, what does that actually mean within sporting context? So imagine yourself on the starting blocks. The force that you're applying to move yourself off the block is your legs pushing down on the starting block, and the opposite reaction to that is the force that the blocks resist. So therefore you're able to move forwards. So we'll put that into a different context here. Imagine you've got this American football player and his foot is pushing off against the dirt there. As he pushes off, some of the dirt might move away. So we could say that that's not giving an equal and opposite reaction. So he may not be able to accelerate quite as quickly as somebody who's maybe on the starting blocks. So the force that's being applied by both these people is the force down into the ground, and this guy down into the starting blocks. But as this turf maybe slips away, we're not getting an exact equal and opposite return. But for this guy here, because he's got the purpose-built starting blocks, it's giving him an exact and equal return or a reaction to the action. Therefore this guy here is obviously going to be able to accelerate a lot quicker. That in principle is the action and reaction. We'll look at this during the sessions using practical examples. Okay, so that's the end of the screencast covering Newton laws and the terminology applied with it. Thanks very much, and we'll do section 2 next week. Cheers.